let's see, it could be creating a bid list. Oh yeah, that's a cool idea. Yeah, so David's saying it could be creating a bid list that automatically gathers bids into a list. Then what you do after is up to you. Okay, so now that makes more sense to me. So we could have a smart contract that bidders can interact with. They can put their bid up, and then even if we stop the development there and don't put much more functionality in, at least then you could go to this thing and view all of the bids, and your interface could go and find the top bid and then do something there. Now, okay, so I'm gonna start writing some of this down here. Let's see, where should I put this? I guess I'm gonna go to HackMD. This is a great tool, by the way. If you don't know about this, this is amazing. It is it's a markdown editor, but it's live and it's collaborative. So in fact, if I go and I make this shareable, how do I share this? I think just this this will work. This link. Here's the link to the HackMD. I think you guys can come on in and edit that and take a look yourself locally if you want. But okay, so I'm just going to do a little bit of brainstorming here. So the idea is to have a contract that accepts bids from users and sort of collates them into a list. And David, sort of feel free to correct me or add more ideas here, but the way I'm sort of interpreting that is that then we will have once the contract is sort of up in a basic form, we'll have an interface for users to make bids, and then we'll have either the same interface or a separate interface to actually list the bids and show highest. And now a last bit of functionality I think that might be nice. And of course, I'm assuming that when the users make bids, they're actually putting the money into the contract. And so it'd be nice if the bid manager, I guess the seller, what would you call that role? What would be a good name? Anybody know of a good name for the role of, for the person who's running the auction? You know, we have users and bids, and they're all going for some service or product, we can imagine. And there's some person that's offering that service or product. So what would we call that person? What's a good name for that role? Manager, producer, provider. You know, we want to make it pretty general in a way, because it'd be nice if people could use this contract for all sorts of things, but at the same time it needs to be specific enough and not too you know, idealistic. Auctioneer, that's perfect. That'll work perfectly. Good idea. So with that, I'm just going to start making some comments into the Solidity here, since we have a name for a role at least. Okay, so we have the Auctioneer role. Here, maybe we do this. Roles. Auctioneer. And then we have, well, we have bidders, but I don't know if the contract needs to keep track of the individuals so much as keep track of the bids. So I'm not going to make that a role. I think maybe there's only one role, and that's an auctioneer, and then the auctioneer can look through the bids and anybody can make a bid. So so I don't know what you would call the bids. I guess that'll be a struct. We'll make a struct for bids. Now another thing I was thinking that might make this thing all a little bit cooler is if the auctioneer can close the auction by selecting one bid. So they would be effectively ending the auction, finalizing it, they would be, I'm just going to call it end bid, and feel free to suggest a better name for that, but the auctioneer is going to select a bid, and these bids will probably have IDs, I think. We can also do hashes. I'm going to go with ID, and that will mean the auction. Let's see here. Let me just think here. So that will transfer the ether in the winning bid, and I'm just going to change this to winning bid ID to the auctioneer, and return all other bids to their whoever made the bids. So this is this could be a cool little thing to make. Now there is a gotcha in here. The gotcha is that is this last line here. So if we want to return all other bids to whoever made the bids, I'm just gonna copy that. You know, maybe it'd be cool to get a whiteboard system going up here. Maybe some of these seminars I could actually do an in-person markers and whiteboard type of stuff. But the problem with that, or the complication, is that requires it requires iteration over an unbounded list. And that's an issue because Solidity runs, or I should say smart contracts run on gas. So if we could imagine that we build this contract and it has not 10, 20 bids, but maybe 100 bids or 500 bids, there's really no limit to how much, how long an array in Solidity can get, unless we impose some limit on it. And now if this list is too big, then the contract will not be able to iterate over all other bids, even with the maximum allowed gas. And so that's an issue. And you can get around it by sort of manually iterating through a list and having it to where when a function is called, it marks where it's going to start, and it goes through a part of the list and then marks where it ended, and then it just flags the process as not yet complete and pauses the rest of the contract. So you can get around it, but even if you do that, then you're requiring the user to make several calls potentially until it iterates through everything. And I'll give you guys an example, because I worked around this once with one of my other contracts on Crypto Primitive Academy I have on here. I was making this, I was calling it the crowd serve contract here. And this is a neat little tool. It's not really complete yet, and I haven't described how it works or what the rules are. But we made a really nice interface, and I'll just show you what it looks like. And the idea is that people can contribute and they can take money back. So, and then at the end of the round, the person trying to raise money can take all of the money out of everyone's account. And it sort of works like tokens that are destroyed every round. Now, here we run into the same iteration issue. So if I go to the Solidity here, crowd serve, let's see here. I wish I could. Well, maybe I'll just. I wish I could get some syntax highlighting on this easily. But let's see here. So here's a contribute function. It's a lot like when someone buys an ERC20 token. We increase a total supply tracker let's see, where's the important bit here? So we increase the balance of the message.sender here. So this contract keeps track of everyone's balance, right? And they have a certain amount of tokens that represents how much money they have in, and that's what lets them recall later their money. So we need to keep track specifically of who put in what on this mapping here. This is a mapping. And again, this first week, a lot of these concepts, what is a mapping? I could go into that. I'm not going to, because we can get into all of these concepts in more depth later. And let me know, this today's stream is definitely as I said, it's improv. So if you guys want to give me any direction, any questions, please feel free. There are no rails to even get off of on this train. It's just a wild train. Tumbling through wherever it goes. Anyway, so yeah, as I was saying, we keep track of the balances for whoever put in money. We need to keep track of how much they put in, so that when they try to recall it, we can give them what they're owed and no more and no less, etc. And on our idea here, we have a similar thing going on, where if we want to return all other bids to whoever made their bids, we need to keep track of how much people made. And as I've sort of been working up to, when you go through and you want to return them, so here I'm going to have a function called try round end. And on the crowd serve, that's when the project manager he said the project is done. I'm going to now end it and basically take all of the earnings that I've made. The crowd serve uses game theory. People can take money out. It works a lot like a burnable payment, actually. But in any case, there's going to come a point where you can end the round. But the problem now is that the contract has to iterate through all of the balances. And so let's see here, if the state is active, we change it. We change it to the ending state. And this is a special state that means that nothing else can go on, and it effectively pauses the rest of the contract. And then here, when you call this, you can tell it how many loops to do, and I don't know how many of these loops. This loop right here is what's going to keep going over and over again, and I don't know. There's going to be some maximum number that let's say it's 50. I don't know if it's 50. Maybe it's 200 or something. It's not a huge number, and anything over that number will never complete in Solidity because it will spend too much gas. And so when you're using this crowd serve contract as the owner of the project, I think I called it the producer. So the producer role, they're expected to produce something for this money raise. If you're the producer here and you want to end the round, you have to sort of experiment. Okay, try 5 max loops, and if that goes, then try 10 and 20, and you'll find there's a maximum that everything fails above that maximum. But I've written this so that when you call it, as long as you request a small enough number of loops to where it doesn't run out of gas completely, this will actually keep track of how far it's gone, and then next time you call it, it will go through the next few. And then finally, if you have gotten to the end of the contract or the end of the list here, then it moves from the ending state into the inactive state, sets some things to 0, and then we're finally back at the initial state of this contract, which is the inactive state. So this whole kind of weird construction here, where I am manually iterating through this and keeping track of where I am, that's just all sort of a general way to get around the fact that we can't iterate through unbounded lists in contracts without worrying about, if the list gets too big, we won't be able to complete it. In a way, just being able to specify the maximum loops helps, but that's not enough. You also need to keep track of where you are in the list, and also pause everything else when you're in the middle of this. If you call this once and it only goes halfway through this list in this loop, you don't want any of your other logic to be going on, because you're sort of in the middle of a state change, and that's what this state.ending helps us do. So I guess, to summarize all that, it's a complicated solution to the, I guess, unavoidable issue that Solidity deals with gas, and if you run out of gas, you run out of processing, and everything aborts. So, so that's I would say, for our purposes here today, that's an issue only because something like this takes some dedicated focus to really do and kind of make sure you're doing it right. I mean, I could copy a lot of this, but I think it'd be better to think about some other ways to do this. So what is the purpose of this? Why do we want to return all other bids to whoever made the bids? Well, that's because, if this is an auction and there's 10 people making bids and one person wins, well, the other 9 people are going to want their money back. But another way we could accomplish that same goal is, well, I am pressing buttons I don't mean to press here. Instead, let's see, what if instead of returning balances, we just allowed people to withdraw manually? And so, in a way, this is sort of simplifying the contract and almost handing it over to game theory, to where we'll just allow people to do it themselves. And if they put money in, they'll want to take it out. And if they don't, I guess they don't care that much. But this way we can avoid iterating through the whole thing. We'll just maybe mark the bid as ended. The auctioneer can they can capture the person, the winning bid's money, and then everybody else can just take their bid out manually. So maybe that is how we'll do it. How's everyone doing? I wonder how many viewers I have here now. We got 4 viewers. Okay. Let's see here. Where am I? Close that. Close that. So I think that's the way that we'll do this. We'll have a contract that accepts bids from users. We'll have an auctioneer that can end bid with a winning bid ID or some kind of identifier to say which bid they prefer. And then once that happens, we'll probably move the auction into an end state to prevent the auctioneer from taking more than one bid. And then just allow people to take their money out of the bids and cancel their bids. And we can probably let people bidders recall or cancel their bid at any time. I don't really see any downside to that. If the only thing I'd worry about a little bit is if the auctioneer tries to end bid with a winning bid at the same time that a bidder is trying to recall their bid. Maybe a question would be, is that going to introduce any complications? And I think that would be fine, because it just depends on which order, these two actions, the end bid or the cancel. I'll just indicate these are functions. If these are included in the same block, the world's not going to explode. It'll just be that one of these goes through first and the other one fails. So and that just depends on how the miner puts together their block. So either the auctioneer will call end bid first, that will come first in the list of transactions, and then the bidders recall or cancel will fail because they found that they've won the bid. And that would be like if you're at a real auction and you go back to the desk and you say, hey, I want to cancel. I need that money. And they'll say, well, the bid just ended and you're the winner. So that's what that would be like. Or if this goes through first in the block and the auctioneer calls end bid, then this will fail, saying that there is no bid, existing like that, because we'll have these functions, invalidate that and clear that bid information. And that would be like if you went to the front desk and you said, I cancel, and then they give you back your money, and then the auctioneer announces you as the winner, but you've already canceled. So they'll have to choose another winner they'll have to try the end bid function again with some other ID. So I think that's a good contract to get started on. I don't know if I don't know how far we'll get. but we can certainly start, and we can start with a much smaller version of this too. So I guess let me move over to the Solidity. I'm going to, let's see, I'm going to copy this. I'm going to put it in here, maybe up here. And I'm just going to shut up for a bit and trim this down to the ideas that we want. Maybe make it a little bit more concise. And then we'll get started on a smaller version of this contract. So let's see. Interface for users. We can take out the interface information now because right now we're just going to be focusing on the contract. Okay, so now we're going to take out this because we don't want to deal with the complication that will come with iterating through everything. I'm going to take that out, and we'll take this weak language out. Bidders can cancel their bid at any time. And then one more we should put in here is that auctioneer can only end bid once for one bid, and we'll enforce that with states. Okay, and I think that's good enough to get started here. And I'm thinking that when I write contracts, I really like to pare down the ideas to the smallest chunk that I can and develop that first. I don't like to develop the whole thing quickly, because if I can develop just the smallest chunk first, then I can test it immediately on Ropsten or even on mainnet sometimes. Well, I suppose first I would test it on the JavaScript VM, and I'll just change that right away now. But anyway, that's I mean, when you're developing any kind of software, you can choose to develop in that way. I'm sure there's a word for it. I know that there's some acronyms out there for it, but the general approach would be to start small, make something that works even in a tiny way, and then test that. And with Solidity specifically, I find that is really a beneficial way to approach it. So, okay, let's get started. Contract. I guess we can call it an auction. There's really no reason not to call it an auction. And we'll leave it general like that. Once we define a lot of the behavior, we might find ourselves inspired to put some more specific name up here, depending on what kind of falls out of our implementation here. And what I'm going to do first is I'm just going to make a contract that can accept bids from users and collate them into a list. So I'm going to put a 1 here. We're just going to just do that. And we're not going to worry about doing anything else here. We're not even going to have the auctioneer role. We're just going to have a contract that lists bids, and they just keep getting added, and you can't cancel them. It's really just an append-only list. And that's relatively simple. We can probably get, I'm sure we can get that. And so let's get started on that. And any questions? No questions so far? All right. So, okay. Well, first thing we need is a list. And that's going to hold bids. And so really the first thing we need is to define what a bid is. And in Solidity, we can define structs, and that's, many of you probably know that's just like a class. Solidity doesn't have classes. It only has contracts and structs. And I believe that these function quite similarly. Of course, the difference is that a contract can be deployed at an address, and you can use it, and it has a balance, and obviously it has all these things that an address would have. And a struct is just a data structure. So we're going to say bid, and I don't think I need a semicolon here, but I might be wrong. But what values do we need? So what do we need to know for a bid? Well, we need to know who the bidder is, and that'll be an address. Bidder, that's pretty easy. We need to know their amount. So uint, and again, uint is a alias for uint 256. I like to just use uints for everything. If I really want to, at the end, I can maybe change this to uint 8 or something. I mean, this is going to be a amount. I'll just say amount. Is that clear enough? But anytime I'm handling an ether, a value amount that's going to hold some amount of ether, I use uint. And remember that this is always going to be stored as a way value. Let's see. Value variables in Solidity are always stored as the way value. And again, if we go to, let's see, Ethereum units, I should have this bookmarked. So if, oh, this isn't even the one that I'm used to. Anyway, so 1 ether is worth tons of way. It's the smallest unit on Ethereum. So anyway, where did my remix go? So a bidder, let's see, bidder, amount. Is there anything else? I suppose, realistically, if there's going to be an auction and you're filling out a piece of paper, imagine you're filling out a piece of paper at the front desk of this auction, or I'm sort of imagining it as a silent auction where the guy's not yelling up there and people aren't really directly competing. It's just more where you go write down a piece of paper and you keep it there, and at the end they announce the winners. And in that case, you would put down your name, and obviously you'd put down how much you're going to pay. You would, when you put down your name, that is sort of serving the purpose of giving them some way to get back to you. It's your handle. So at the end of the auction, they'd say, okay, Bob Jones, they'd say, and they'd come find you. And that's because you put your name down. And here we have the address. But I guess what I'm getting to is it'd be nice if there was, I almost just want to make it really general, like extra data or, delivery instructions or something. But it'd be nice if when you make a bid, you can add some more data. For example, email me the thing at, here's my email address, or, here's my phone number, or some way to help the auctioneer actually deliver whatever it is that he's offering. I'm going to put it in there. And of course, as a user, you can always just leave it blank and trust that the auctioneer maybe knows you in person, or, they're going to have your address. And so even if you leave this blank, as long as the auctioneer is honest, you can always contact him and prove that you're the bidder, and then he'll give you whatever it is. And another thing to note is that this whole design assumes that the auctioneer is trustworthy. And that might kind of worry some, blockchain users, because blockchains are supposed to remove trust or remove the need for trust. But, I think that on the internet, there's a lot of people with strong reputations that could use this quite well. And if you just assume that one role in a smart contract is a trusted role, some community trusted member, you can pretty quickly make a contract that's actually still quite useful. All right, so I think that's enough for the bid struct. I'm just going to compile this and make sure my syntax is correct, and it does seem to be correct because it popped up right here. Look at the details. Yeah, so that clearly compiled. And okay, so we have a struct for a bid. So now let's make an array. I suppose we want to keep track of these bids. And let me go and look at Solidity docs. I want to make sure that I'm getting the array usage right. Let's just do like this. Oops. Array types. I think that's what we want. Yes. And Control F for array. And let's see. Address. So we've got fixed size byte arrays. We don't want that. Address literals. Okay, let's go next here. Oh goodness. Oh, dynamic. That's still byte array. We don't want byte arrays. Arrays. You know what? I'm going to just go look at a contract that I've written before that I know uses an array in the way that I want to use it, and that is on Toastycoin, VLP. The contract, the factory contract, keeps a dynamically sized array, and that's how we do it, just right there. Okay, so back to Remix. So, oh, well, we don't want address, we want bid. Okay, let's go to public. Is that all we need? Just the name, yeah. Bids. So what we're doing here is we're just saying that there's going to be an array of bids, and when you start it like this, that makes it dynamic, so we can add as many as we want onto this list here. Public means that anybody can. Really, what this means is that it'll automatically generate a getter. So if I compile this and I go to run, I can deploy it real quick, and this is all in the VM again, so this is going to be really quick. So we have the auction here. So when I made this public, what we get is this automatically generated getter. So this is a function that will return a value to me, and you'll see it's asking for an integer. And that's because we're looking at an array, and to get something from this list, we need to give it the an integer, a iterator, I should say. Of course, it's empty right now, so no matter what I put in, it'll just give me an empty. It'll just fail actually because there's nothing in there yet. So, okay, so now we have a list that's empty that can hold these bids. Now let's make a function to actually add a bid. So this is going to be like the first functional bit of code we're writing here. Hey, 7 viewers, that's cool. Okay, all right, let's see. I need to do some cleaning here. Can't let these tabs get out of control. Close that, close that. Okay, and close that for now too. All right, so function. Let's see, I guess make bid, right? And then as part of that, and this is going to be something that the bidder calls. So if you want to make a bid, and the information you need to pass in is the amount you want to. I'll just call that bid amount. String extra data. Okay. So then we'll have, and I'll put some underscores here. And I guess I'll just call this amount. That's pretty clear, I think. Speak up if you have a better way to refer to the amount of ether being passed or specified. And actually I just realized we don't even need to pass this in as a variable. And here's why. So we can take all that out. Now we're going to make this payable, right? Because this is a function that the user passes money with, right? If he's making a bid, he needs to actually give the money to the contract. And so we'll make it payable, and then within this we'll just say message.value. So we'll be able to see with this this special variable, how much they've actually passed through. So we don't need to actually take an argument, because we're just going to look at how much they actually sent with it. And in a similar way, we don't need to ask what their address is, because we'll just say message.sender. So within this function, we're going to make a bid. We're going to make a new bid. Let's see here, bids.push, and then let's again solidity struct. Let's just make sure I'm using this right. Structs. Struct funder. Struct. Let's see. So you just like C++, when you're making a new object from a class, you just call the name and you pass in. It looks like yeah, it looks like we can just pass in arguments with the same order they have in the definition. So let's go back here, and we will say bid, and then the bid needs the bidder, the amount, and the extra data. So we'll say message.sender for the address, message.value for the amount, and then extra data will pass in from our function argument here. And that's about it. I think that'll work. It's pretty cool how simple you can make these smart contracts sometimes. So let's clear this old one here, and let's deploy again. Oh, I need to recompile. And see, this is an example of a gotcha. It's sort of a frustrating thing about Remix that that Pragma has solved, and it's just too bad Pragma is being buggy, because if you change this, you might be sort of fooled into redeploying and thinking, okay, now I have the new code, but that doesn't actually work. You have to go back here, go to compile first, and then you'd go back to run. There's been a number of times where I sort of forgot that step, and I was really confused as to why my code wasn't doing what it should. Before we go to run, I'm going to check out this no visibility specified. Yeah, that's a good thing. We're going to make this external because it's made to be called by the users of this. And it's important to keep in mind when you're designing a smart contract, when you are making an external function like make bid, it's easier to imagine that a human is going to be making this call directly, but you sort of want to keep in the back of your mind that it could also be some script or some server somewhere making a bid. And that's fine. There's no need really for simple smart contracts to make sure that no computer can get in. There's no room for CAPTCHAs here. If you design a contract with the awareness that scripts can be calling it too, as long as your game theory is solid, that doesn't actually end up being a bad thing. And really it makes it more usable, especially when we talk about cryptoeconomic primitives. These primitives should be usable by scripts and other larger systems, because it's a lot of their advertised utilities that they can be used as building blocks. So anyway, my point there is just when you're writing a function and you make it external, keep in mind, you can imagine that a user is using this, but also keep in mind that that computers and scripts and robots and all those sci-fi stuff might be using this too. All right, so I made it external. I'm going to compile again. I usually ignore these static analysis. I wouldn't recommend that you ignore them. I suppose I'm just pretty comfortable these days with Solidity. So gas requirement of function I and infinite. See, now I believe this is referring to the fact that this is a dynamically sized array, and so it's sort of talking about the same issue I was talking about before, where if you try to iterate over something, and the thing is too big, then you're going to run out of gas. And it's getting to the same idea here, where it's saying the gas requirement of function auction.bids is high, infinite. So yeah, please avoid loops in your function. So you can tell it's talking about the same thing. I'm going to dismiss those for now, because we're not really iterating over any of this. The only thing we're doing so far with this list is pushing, and that doesn't have to iterate. That just looks at the length and adds another thing at the end. Pretty sure that doesn't have to iterate anyway. There's no internal iteration. Okay, so we compiled, and we can see that the compile button is no longer lit up. So that is a little visual clue that you need to compile. But anyway, we're going to deploy now. All right. Now we have another function here, make bid, and we can put in our extra data, and it's going to take our address and however much we send with it, and that's what it's going to use to build this bid. So I am going to use, I guess I'll just use this first address. We don't really have a lot of complicated roles. There's not a lot of point in juggling around these identities. I'm just going to keep it on this one guy. So let's copy. Well, we don't need to copy his address. We'll just select him. And we'll say we're going to send 1 Ether along with this, so that'll be the bid amount. And then we can specify some extra data. I'll put something in there, I guess. Yo, what up? And make bid. And we have an error, syntax error, unexpected token Y in JSON. Oh, that is an ugly error. And I don't even know what it means. You know, I bet I have to put quotes around this. Let's try that. There we go. So I had to put quotes around this. And this is just, you have to remember that this is a tool for calling a function of a contract. And this function could have just as easily taken a few arguments. And so it might seem weird to you that I can't just do this, right? Like that should work. But you got to remember that this is going to be potentially any of these boxes here. So if we have a bunch of functions here, we're going to have a lot of boxes. And any of these boxes could be expecting several inputs. So, you know, we could have had like that, maybe a number and maybe another string, right? And when I have it like that, it makes sense that you would need to put quotes around your strings. When you're only supplying one string value, it's less obvious. So that might be confusing. But so anyway, we do need quotes around that. And this looks like it passed, or it looks like it went successfully because we see this this transaction here, and there was no error. So now we should be able to, if this function went correctly, then we should have one bid here, and we should be able to access that by putting the 0 iterator in and clicking on bids, and here we go. So it's giving us the information here. There's my extra data, my amount there, and as I said, this is in a way we can go to the unit, Ethereum units. I'm going to actually bookmark this right now. Bookmarks bar, units. There we go. So that'll be nice. We can put in here. Yep, looks like that's 1 Ether. No big surprise there. Back to Remix here, and yeah, this is my address, CA3. You'll notice that the capitalizations here are different. This is a bit silly. With Bitcoin addresses, it matters which ones are capitalized. Pretty much the whole industry makes sure that you capitalize the address in certain ways. And Ethereum tried to do the same thing, but there's not really clear consensus on how to do it. So sometimes you'll see, you know, these two addresses are equivalent, sort of regardless of the capitalization. But if you look at this one, you'll notice that some letters are capitalized and some letters are not. And they use that as a way of doing a checksum. And so some interfaces, like Web3 Pi, for example, it's not really an interface, it's more of a tool, but some tools or interfaces will require that you pass it in with the checksum as part of it. And so if I'd passed this into Web3 Pi, that would have worked, whereas if I'd passed this one, which is all lowercase, and I wonder if I copy and paste, if that pops out. See, this pops out all lowercase here. And so if I tried to take this and pop it into Web3 Pi, that would give me an error. I would have had to somehow recover again those the checksummed version, which has this upper and lower case. Anyway, so this so we're now complete. We finished number 1 there. Contract that accepts bids from users and collates them into a list. And, I mean, we also know that the bid the auction contract actually has this money in there. Because we're on the VM, we can't see that, or at least I haven't figured out a way to see that. We can see that it went away from this account. You can see it has 1 less ether, so we can reason, well, there's only one place it could have gone in our little VM that's at this contract. It didn't go to any of our other addresses. It'd be nice if we could see it directly. If we went to injected Web3 and then deployed this all on Ropsten, then we could go and look at it on Etherscan. I'm not going to worry too much about it right now, but that would be a way that we can see it. We could also, I guess, if we want to, we could sort of put a function in here that we don't intend to keep in, for the whole life cycle, or for the deployment, the deployed version, the finished version. But we can just say balance. We can make it constant, I believe, and we can say return address this balance. I think that works. Let's see if it compiles. No. Different number of arguments in return. Oh, yeah. So this is the first time that I've returned something on this stream. And I forgot you need to tell it what you're going to return. Returns address. I think that's the syntax. Constant. Expected curly brace. I think maybe this needs to go right before the curly brace. Let's try that. Let's try that. No. Oh, yeah. That's right. I'm not returning an address. I'm returning a uint. Let's try that. There we go. I have a warning now. No visibility specified. We'll make it. I wonder if pure works. No. Let's just do let's do external. That'll be fine. And we still have an error. Mutability can okay, that's what we want. View. So a view, I believe it's a lot like an external, but a view is even more restrictive, and it just specifies that this function is not going to be doing any state changes. It's just going to be viewing information, which is indeed what all that does. We still get a. Oh, I guess that's the view is different. I thought the view was a visibility thing, but it's not. So I guess I can just do external view. I wonder if that works. Okay, that works. All right, let's go back here. Now we can just do the same test again. Deploy. And we're going to make bid, blah, blah, blah. We're going to put 1 ether, do that. And now, once again, if we go to bid 0, we'll see it there. And we can now also click get balance. And there is, we can see that's returning the balance of this. And indeed, we can see the 1 ether there. Okay. I'm just going to put a comment here. Remove after yeah. Okay. Okay, so we got an auction contract that can keep track of bids. Now let's see what else we can tackle here. What time is it? Dang, it's already an hour 20 in. Let's see how many viewers I got. I'm happy to keep going here for a little while longer. 7 views. Okay, cool. And guys, stop me with any questions. Now is a good stopping point. Say something on Slack if you want. Oh, I got some questions here. Yes. So the first thing, yes, I really You can auto compile if you want. I don't like to, because this whole thing is running just as a a web page, which doesn't have a lot of access to your resources on your computer. So if you click compile, I guess it's pretty fast on this laptop I'm using right now. On my old laptop, when I clicked this, everything froze for a good 4 seconds, 7-10 seconds. I guess I will check that for now, because this seems to be quite fast on this PC. I'm using a little web, like it's almost like it looks like a Chromebook. I mean, it's not, but it's a little light little thing, and maybe it just has a really good hardware for website use and JavaScript running. So yeah, check uncheck that as you like. As I said, I usually keep it unchecked because my old PC, whenever it would compile, as soon as I finished writing any kind of lines of code that was valid anyway, then it would start to compile. You saw it kind of flash there, maybe. But here it seems to be so quick that that's actually a good thing to have on. So good job pointing that out. And then ETH using hex values for addresses. So upper or lowercase is absolute irrelevant. Yeah, so that's true. I mean, that's true enough. And then when you look at an address, so I'll use Etherscan as a good example. Let's go back to Remix. Let's go grab one of these addresses, copy. This will kind of help illustrate what I'm talking about here. So when I paste this, it's clear that it's copied everything just as lowercase. There's no uppercase here. And that's valid hex. I mean, as I'm sure you know, you just look at every pair of these, and you build a byte from CA, build a byte from 3.5, build a byte from B7. So that's valid hex. And most tools will accept that as an Ethereum address. Etherscan will as well. But you'll notice when we click go, we'll go to the page. Whoops! It actually converts for us into this mixed case hex value, or not value, but a mixed case hex output. And the intended utility of that is that now if I take this and I put it into another tool that uses this, well, I guess we'll call it a standard, like Web3 Pi, by looking at which, and I don't know the details of this process, but by looking at which of these letters is uppercase and lowercase, it can interpret that in a way to do a checksum and actually verify that it's a valid address. And Bitcoin does that automatically. So when you use a Bitcoin address, if you were to go and try to hand type in a Bitcoin address, and if you got one character wrong, most of the time it would say you did something wrong, and it wouldn't try to send the money to that invalid address. But with Ethereum, if you just use this lowercase version, and then maybe I change this C to a D, I believe that you can still send money there because there's no checksum in here. It's just another address value. But if you use this checksummed version, and then I accidentally change this C to a D, as long as you're using a tool that uses the same standard like Web3 Pi, then it will catch that because the checksum no longer works. So that is, the weirdness with these addresses. As I said, most tools don't care, which is good and bad. I mean, it's nice that most tools aren't picky. At the same time, though, it means we don't have that checksum tool. I don't know how important the checksum tool is, considering that everyone is always going to be copy and pasting stuff. I mean, you're never going to be hand typing in anything, any kind of address. And in fact, a lot of times you're going to be scanning QR codes in the real world. So I don't know how important it is that we have this checksum stuff going on. But anyway, that is what's going on there. So it's just so you guys know. Okay, let's see. Any other questions on? Yep. Okay. Thanks for the question, Sayron. It's good to get me off the track and then back on here. This is good. Okay, that was a good break too. So now number one is done, and in fact I'll just put a little satisfying done thing there. So what else do we have here? Let's see. Auctioneer can end bid. Bidders can recall or cancel their bid. Auctioneer can only end bid once for one bid. Let's see. I'm deciding between. Here, I'm just gonna number all these. in fact, I'm going to say A, B, C, because I don't know, whoops, I don't know which order I want to do these in, so I don't want to put numbers. I'm hesitating. I'm trying to decide between B and C. B would be nice because we can start defining this auctioneer role, and it would make it a little bit more interesting. C would be nice because we could sort of complete a lot of the bidding, the bid submitters functionality, because it'd be nice if you could put something in and withdraw it. I guess I'm going to do bidders, the C first, because that won't be too complicated. It's pretty simple, I think. So, and that is we're going to try to enable the this recall or cancel functionality here. So, and I have to decide on a name now as well. Let's see. I suppose recall is a fine. Recall bid. Okay. And now let me just think here. Now we have a list of bids. So every bid is going to have a specific position in that array there. And when you recall a bid, you're going to want to be able to directly reference the bid. So now it's possible we could try to design this function with no argument, right? And we could say, okay, what is the message.sender, and then iterate through to find the bid with the bidder equal to message.sender. Of course, the problem there is that we're iterating through, and we want to avoid that. And so instead of doing that, and plus there could be multiple bids. I mean, if one person sent in 3 bids, this is just going to find the first one. And so that's really just not a good solution. So instead of doing that, we're going to require that the user submits their the identifier and bid iterator. Okay, and now since we're doing that, before going on here, I'm going to go back to our make bid, and I'm going to return, let's see, bids.length -1. And that's going to return to them the position in the list that their new bid. So when we call this make bid function, it's going to actually give us a return value of wherever our bid actually is in the list. So that'll be easier for us to grab that number and put it into this function later when we want to recall the bid. We'll also use the same that same way of referencing when we start talking about how the auctioneer can end bid with the winning bid ID. In fact, I'll just change this right now, iterator. So we'll reference the bid in the same way. And then one other thing is that we have to now change this, say returns unit. And you can actually name what you're going to return. So I'm going to keep it like this, but I'm going to change it quick and show you another way you can do it, and then change it right back. Just because it's an interesting tool that I don't use. And I really just don't use it because it's just not my style. There's no any other reason I'm not using it. So I'll just show it to you guys so you can see it. You can name the return variable up here. So I could say returns uint bid iterator like this, and then down here, instead of saying return bids.length, I could just say bid iterator equals, and I believe that compiles actually just like that, and indeed it does. Oh, it's auto compiled actually, so that's nice. So that is a way that you can do it. I maybe this is fine, maybe it's good style. I haven't gotten into the habit. That's at the very least, and at least this way it's a little bit more explicit that we're actually returning this value. I believe you can maybe you could even still bid iterator. I think you can even maybe name it and say returns. Yeah, so I can even name it up here, and I think that that actually ends up showing up on the ABI, which means that, and the ABI is again what you pass to any interface you're going to be building with this. So then that means the interface would potentially be aware of this name. So that seems like a good thing. So I guess I'll keep that name in there, and I'll go down to my other returns here, and I'll just even do the same here. Okay, so back to recall bid here. So the caller has passed in the bid iterator, and they want to return the bid. They want to recall that bid. Now, the first thing that comes to my mind is we want to make sure that they own this bid. That they, we don't want any user to be able to come and recall any bid, because then they could just clean out the whole contract. So we will say require. So we're going to have some well, let me write the line first, and then I'll talk more about it here. Require that message.sender equals bid iterator dot bidder. And I think what I'm going to do is change the name in the struct to bidder address, just to make some, like this code is now a little bit more readable here, because I'm saying bidder address. So I'm going to go and find that elsewhere and change it to bidder address. Oh, I don't have it anywhere else. Okay, that's fine. Okay. And we have a warning here. This autocompile is really actually quite nice. Now that I have a computer that can handle it. No visibility, that's right. So we want this to be external. Okay. State mutability can be restricted to view. It's only saying that because I haven't actually done a lot in this function yet. So as soon as I actually do something to the state of this warning is going to go away, because right now it's just telling me that nothing is really changing, so I can change it to view. The state mutability can be restricted to view. That's not going to be true as I develop this, so I'm just going to ignore this this warning now. Okay, so what do we want to do? Well, we want to, now that we know that the caller of this function is the owner, or sorry, is the registered address for the bid at bid iterator, that's all good. Another thing that we could require is require that bid iterator is less than bids.length. Yeah, so if there's one less than or equal to, let me think about this. I always get a little confused with list lengths. So if there's one bid in here, this is going to return 1. And we'd want this to fail if they put in a 1. So that would fail. This would only pass if it's 0. I think that's correct. Okay. So we're sure now that bid iterator, it refers to something in the list. We're also sure that the bidder address is the same as the message.sender. And okay. And now let's also require that the bid we're looking at actually has something in it. Because when we're done with this function, I'm planning to just set the balance, or sorry, the amount of the bid to 0, and that'll be our way of not really deleting it from the list, but sort of deactivating or invalidating the bid there. We're going to set the amount to 0 because a bid with a 0 on it is sort of a null indication there that it's an indication that it's not really valid anymore. So this way I'm gonna make sure that once a bid has been recalled through this function, or if the amount has been set to 0 in some other way, then we can't recall the bid anymore, which seems like a good requirement. And I guess as I'm speaking aloud through this, I do this a lot where before I even get to anything about what the function's actually going to do, I really define all of the checks that I want to go into it at first, and really think about I want to restrict the cases in which this function is going to actually succeed. And this require statement is a great way to do it. And another cool thing about these require statements is that you can actually add in as a second argument the reason for the failure. So here I can say invalid bid iterator. Okay, and here I can say let's see, incorrect bid owner, or maybe just you are not the bid owner, or well, message.sender doesn't equal bid owner. Okay, but I should really match this up to our terminology here. And then here I can say bid, well, it has nothing in it, empty bid. Bid is empty, boarding. Okay, all right, so I think that's all that requires I can think of. If you guys have any ideas, oh, no, please ask. Better data type to store bids. Yeah, so we could use a mapping probably. Let me try to think about why I chose an array instead of a mapping. So yeah, so Sayron's asking, sorry for asking in, but is there a better data type to store bids? Something like sorted mapping, so you could find all bids from a message.sender without iterating the complete array. Yeah, we could have used a mapping, and instead of let's see, so I think Sayron is talking about using a mapping to, instead of keeping track of specific bids, we'd be keeping track of the bidders, the people that are doing the bidding, and then we would just keep track of the total that they have bid so far. So we could do that, and my initial gut reaction is just to say that that is sort of an equally valid way to approach this. But it would change our design to where right now we have this struct of a bid, and we have this array of discrete bids, and we can reason about the bids. You'll see I'm not really building any of this logic around the identity of the bidders, but rather the individual bids. And if instead we used a mapping, so we could instead do a mapping, and I'm going to delete this after it's here or comment it out, because I want to, now that we've started developing it this way, I want to keep going this way, but we could make a mapping, and a mapping is like a dictionary in Solidity. You can map one type of variable to another type of variable, and it works as a key and value of a dictionary. So we could say mapping from address to I guess we could say amount, well, uint, right? And then we would call it bidder balances, like that. And then for every address, when someone makes a bid, instead of making a new bid object, we would add however much they've sent on this payable function. We would just add it to we would say, okay, go to that address and add however much they've sent to the balance at that bid location. Mappings can be a little bit confusing without fully fleshing out an example, and I don't want to get off the rails here too much. But just to answer the question that Sayron had, we could instead go through this and make a mapping of addresses to uinteger, which would indicate their balances. We could also map this to some other struct, right? And make a different kind of struct. But the key difference here is that we'd be organizing by address, so organizing it by who put it in, and that would be a legitimate way to build this, especially when you consider, like, why would you want a bidder to have multiple bids for the same item? It doesn't really make sense. So in a way, this makes this this avoids that problem where it's organizing everything by bidder. So every individual bidder would have one and only one representation of how much of a bid they put in. So that's a legitimate way to build this. And in fact, if anybody wants to build this in that way, rebuild this either after the stream or even now, feel free to get started on that. Ask me questions, and I'd be happy to help. And if anybody does that, I would love to actually share it on the Slack and on the blog. Really, as I said, I'm leading these as sort of an instructor role for now, but I really want this to be as open source as possible. So, all right. So, but we're not going to do that. We're going to stick with this bid system, and partially it's just because how the idea was initially suggested to me. And we can always go back, maybe in a different seminar also, and rebuild it. Okay, so I think we had another question here. Will there be a problem? Yeah, I'm glad you learned a lot. Okay, so will there be a problem if somebody tries to submit multiple bids? Yeah, so that's a good question. It's been in the back of my mind as I've been designing this, and I think so far the answer is no. And that's because we're designing this to reference specific bids. So you can make a bid and it's going to return the bid iterator to you. So whenever you make a bid, you'll get a little handle on how to reference it. And then we only have one function that deals with any specific bid. But with that one, you have to specifically reference which bid you make. So if you make 3 bids, and then you want to recall a bid, you still have to actually specify which one you want to recall. And as long as whenever we're building a function that does something with any specific bid, as long as you make sure that the user explicitly references the bid that they want to affect, we shouldn't run into any issues. Maybe if you are using this and you don't really know what's going on, maybe if it's a confusing interface, you might make 2 bids when you only meant to make 1. I mean, I guess I could imagine that. And then if you don't notice that the money's gone, maybe you would not realize that there's 2 bids in there, and you maybe would forget about one of them and leave the money in there. But that, I sort of want to say that's not really an emergency, terrible critical bug to fix on the contract side. I think that would be a bug to fix on the interface side, where if you had an interface that made sure the interface keeps track of all of the bids you've made and gives you a button for each bid to recall it, then it wouldn't really matter that there's 5 or 7 or 20, as long as you can go and individually recall each one. And as long as we build everything around referencing a bid with this bid iterator, that should be possible. And that kind of answer is sort of offloading that design complication to the interface, but I think that's generally a good practice. You want the contract to be as simple as possible, and as long as you really just want to give the tools, you want to provide the tools necessary for an interface to come and use the contract intelligently. All right, keep the questions coming, guys. This is good. So we have all our requirements, our require statements here. We've sort of limited the cases in which this will fire. So we know that it's only going to fire if the bid iterator is valid, if this command is coming from the owner of the bidder, and if there's actually something in the bid. So we can actually now do the recall. So you want to be mindful of the order of the statements that you're putting in here because of re-entrancy attacks. And here I'm just going to re-entrancy. Whoops, I want to specify a little bit more here. Ethereum. Yeah, so this is a really good security topic to get into. I'm not going to get into it, but I'm just going to keep this tab open, and then later when I post this video, I'm gonna also post this this link. And this re-entrancy issue really just means that you want to be mindful of the order in which you put these down. So I will show you the correct order for this contract, and then if you want to know more of the theory, I would read this, read all about re-entrancy, and it'll be a little bit clearer after I actually put the lines down. I'm going to put all the lines down and then reorder them if I need to. So one thing that we'd want to do, obviously, is actually send the money back to the bidder. So we'll need to know how much is in the bid. So that's going to be bids bid iterator amount, and we're going to want to transfer that to the bidder address, bids bid iterator bidder address dot transfer, just like that. Put a semicolon. So it's kind of a long line. I wonder if there's an easier way to split this up. I'm going to leave it as it is now. So again, what we're doing is there's sort of two halves to this. First half is we're just getting the address to send it to. The second half we're actually transferring, and we're transferring the amount there. And now we also, another action we want to do, and we're going to reorder these in a second. So we're going to think about the order of this line and the one I'm about to write after I write the second line. But before we do that, I'm just going to write it out. So we've sent the amount. We also want to register that we've sent that away. So we're going to say bids bid iterator dot amount equals 0, like that. So we're doing two actions here. One is we're actually sending the money away, and one is we're sort of clearing our own memory of that amount from our bid list here. So okay, now let's talk about the order of these two. I believe that somewhere down here it's going to talk about the fix for this. I can talk about it. I hope that there's a quick I can't find it here. There's when you're doing something like this, you want to reflect the change before you actually send off the money. And again, I don't want to get too into the re-entrancy attack, but you can already tell from the words there, it has to do with a function being a little bit susceptible to being called multiple times before it resolves. And, you know, I actually think that's only possible if the issue is that when you transfer to another contract, well, especially when you send. So if I was going to do send, send has a chance of triggering a function in. So okay, let me back up a little bit. This is an address, right? If that was an address of a smart contract, and if that smart contract had some code that was triggerable upon a send, then this line would trigger that smart contract function, and that function could then recall this, and that is when you run into a re-entrancy bug, because that means this line would not have finished yet, and this function is being called again. And so if we did that, right, and if this line was down here instead, to where this, so, you know, we have this being called, it calls this line here, it sends to the foreign contract, and before it's finished now, this foreign contract is going to recall into here. What we've done is we've sent the money, or we've at least started the send call without actually having set this amount to 0. And so in this case, we want to put this line up here, because that way we've cleared our local amount here before sending it off, and so that kind of prevents a whole class of bugs. This reentrancy attack here is what happened with the DAO-zaster, the first DAO we had, the decentralized autonomous organization. Here's another link, the DAO-zaster. That should find it. Nope, the DAO-zaster. Maybe I have to put quotes around it. Oh my goodness. I thought it would be easy to find that way. Maybe just the DAO reentrancy. Yeah, so here's another link that I will include. This was a huge issue. Lots of money was stolen, so look into that. I'm going to move on for now. I don't want to keep talking about this, especially for this first week, and we're already almost on 2 hours now. So I'm just going to move on, but at least know that for this contract, putting it in this order, and also you don't want to use send, you want to use transfer. That also prevents this class of attack. You can never be too careful with smart contracts, so I'm really just, this reentrancy thing is a pretty big issue with smart contracts, and if you know what you're doing, you can avoid it pretty well. So I'm just going to be safe. I'm going to put these in the right order, and I'm also going to use transfer, and both of those things should prevent any kind of reentrancy attack. Okay, so we've set the amount to 0 and we've sent it off, and I think that might be all we need to do. Now, after this completes, there will still be a bid in the bid list, but it'll be a bid with an amount equal to 0, and that later, when we're doing anything with bids, we can check, just like we did here. So see how we check here, make sure the amount is greater than 0. So that right there means that you can only recall bid once, every time, because as soon as you call this once, it's going to set the amount to 0, and then if you call it again, this require will fail, and it'll say bid is empty, aborting. And so if we include a similar check on other functions that reference any kind of specific bid, then we can deal with the fact that our array will hold bids that are invalid. And we could, I think in theory, delete something from the array, but if we delete it and then try to how to explain this? If we were using something like JavaScript, we could just delete the element from the list and move on. But when you delete something from a list, let's say we have a list here and we have some values in this list, right? And we want to delete one of these. We can clear it, right, and leave an empty space in there, but that's still going to be in the array. And if you do this, and if you delete something in like a JavaScript list, for example, it not only deletes it or clears it, but it also removes it from the list, which means that all of these items are going to move up one position. See, like that. And to do that action, I mean, it seems simple when I'm doing it here, on the keyboard, but to do that is going to involve some iteration. I'm pretty sure in Solidity, because it needs to, first it clears the value here, then it needs to move everything back. It needs to sort of re-sew this array back together. To do that little move there, and that not only does that require some iteration, but it also invalidates the positions of any of these. So this last item here is the 0, 1, 2, 3, 4, 5, 6, 7, and the iterator 7 would reference that last one. If we delete something out of this, then now our iterator of 7 is referring to an invalid thing, and in fact all of these now have incorrect iterators. So So all that to just to say, we just deleting something from the array is not really a valid approach here. In Solidity, I've found you just want to sort of indicate that it is inactive. And we could even do that. We could do that explicitly if we wanted. We could say bool valid, like that. And then in here we could say true, right? And then here we could say bid iterator dot valid equals false. We could do that. I'm tempted almost just to do that like that. Why not? I mean, we're adding a little bit of logic here to the smart contract, but we're also making it more explicit. And then we can change this line here. Require that it's valid. And that's it's a little bit clearer. And then we'll move this up here again. So we're reflecting the local state change before sending that money out. And I'm gonna, yeah, I think that's good. I'm also gonna keep this line in, setting the amount to 0, just because that, you know, why not? Just in case we miss some check elsewhere, at least the amount is set to 0, so it's not gonna be sort of mistakenly believing that there's money in there when there's not. Okay, we're already up on almost 2 hours on the stream, although I suppose I started late. So I think I'm going to end here pretty soon. So I want to test out this recall bid bit here. So autocompile is done. There's no errors. I'm going to clear this old version, redeploy. And so what do we want to do? We want to make a bid and see if we can recall it. And then we'll also check to make sure that the structure of a bid within that bid's then the bid array is reflecting what it should. See if there's any questions yet. Isn't I called resize event? Not sure what you mean by that. Let's see here. So yeah, Seiron, I don't know what you meant by that last question. If you want to rephrase, feel free. Also, I'm not actually getting any sounds notifying of my my Slack, so I don't know. Oh, you know, it's because it has me as do not disturb. That's annoying. Okay, well, I should be able to hear when the, yeah, there it goes. Isn't I called a resize? Yes. Oh, isn't it called a resize event? Yeah, everything I was just talking about with the arrays, that is called a resize event. I mean, that definitely references what I'm talking about. Yeah, that's the idea. And you just want to be careful. You know, a lot of the languages do that stuff automatically because we're just not as concerned with the computational cost. But with Solidity, we're quite concerned with that, especially when we start dealing with arrays, because you might be iterating over a huge list, and if it's too big, that might run you out of gas. So I like to avoid all that. Okay, so let's make a bid. Let's put 1 ether into this bid, and we can put in a string of extra data. I'm just going to put an empty string. I'm not really too worried about it. And make bid. Okay, that seems to have gone through successfully. And now remember that our make bid returns something, and I think we can find that return value in here. Of course, we know what it's going to be. It's going to be 0, but I believe we can actually find that. Yes, decoded output. There it is, 0. So we know that our bid is an ID of 0, and in fact, we can just make another bid, and I'm just going to do that just to make sure that that gives us a 1. That's what it should do, right? Make bid, and now it should have returned a 1. And it does. Oh yeah. Oh, bid iterator 1. That's what I should have been looking at. Oh, and there's the name. So that bid iterator, that name right there, is coming from the fact that I named it right here, and it's returning 1. Okay. All right. So now we have two bids. We can check the bid 0, and there it is. We can check bid 1. They'll have, oh, now see my value went to 0, so bid 1 should have a value of 0, which is a little silly that the bid amount is 0. If we wanted to, one thing that would be good is in make bid, I'm just going to put this in now, require that message.value is greater than 0. And you could change this to some small value if you want to make a minimum bid. I'm just going to require that it has any kind of value included. I'm not going to redeploy. I'm just going to keep going with the older version here, but that's a good check to have. In any case, we have two bids now. We have bid 1, or bid 0 and bid 1. And now I want to try to recall one of these. So since bid 0 here actually has something in it, I'm going to try to recall bid 0. I guess I'll get balance just to see what it is. So there we go. We got 1 Ether in there. Okay, let's see what happens. Recall bid. Seems to have gone through successfully. I didn't get any errors. So now if I get balance, it should be 0. No, it's not. Let's see here. Let's see what happened to the bid 0. Okay, valid is false. So clearly this code executed and the amount is 0. But the contract balance is still the 1, which means it didn't send that back. And but my account here seems to have the Ether back. See, it's almost 100 Ether, which is what they start out with, minus some gas costs. So what happened here? Why is, I wonder if this view is messing us up, because this balance should be 0. It should be. I mean, the contract shouldn't have anything in it because all of our Ether is back here minus the gas cost. I'm just going to take out view, and I'm going to close, redeploy, and now autocompile is checked. Thanks once again to Seiron for mentioning that. So now I'm going to redeploy, make a bid. Let's see, 1 Ether. Empty string, make bid. Okay, get balance. It didn't show me anything here. I wonder if it decoded output balance 1000. Okay, now let's try to recall the bid 0, recall. And now let's go to get balance again and see what it says here. Output. Still 1000. That's interesting. Not sure what's going on here. Bids 0, the amount. So it cleared that out. And it transferred to this address the amount. Oh, this is obvious. Okay, I set the amount to 0. Before putting it in here, so it's sending 0 at each time. So okay, that's the bug. So what we'll just fix this by going and saying amount to send equals bids bid iterator amount. Then we set it to 0, and then instead of putting this here, we say amount to send. That'll do it. Okay, let's try this all again. So, deploy. I'm going to make a bid of 1 Ether with an empty string. Make bid. Okay, let's check the balance. That should be 1000. Or, not 1 with a bunch of zeros anyway, which is about 1 Ether. Okay, and let's check the bid at 0. Here's my address. There's the amount. There's nothing in the extra data. It's valid. Now we're going to recall bid 0. went by without an error. Check bid 0 again, now 0, so that all worked. And now we should be able to get balance, check it, and now it should be 0. There it is, 0 balance, and the money has reappeared in my account. So that is, I'm going to stop there. Well, first of all, I'm going to say done, because it is done. And I'll stop there this stream. I'd like to keep going. I just don't want to make these streams too long. But considering the plan today was to do a blitz of multiple contracts, and we're still on the same one, I will end there. We'll maybe get back into this auction contract. I think it is a pretty good project to work on in these early days. It's pretty straightforward, but without being too crazy boring, I think. So we'll probably pick this up maybe tomorrow, certainly by Monday. Let's see what we have for the schedule. Where did my blog go? Any questions? Nope. End of the page here. First week, Friday, I'll give a general introduction to alternative interface options. So I won't get to the Solidity tomorrow. I'll be focusing on probably mostly just Web3 Pi. But by Monday of next week, the general weekly schedule is that on Mondays we're going to be contract design and development. So since we're already halfway through this and we've made some encouraging progress, I'll probably just pick this up on Monday, and we'll work on B and D. So we'll have to actually define the whole auctioneer role, and we'll do some stuff with states. There's nothing magical about states. It's just a way of internally tracking what's going on with the contract, which is pretty important for making sure that certain things can only happen in certain times in the life cycle. In particular, it's going to make sure that our auctioneer can only end bid once. So we'll use states, and we'll sort of define. We'll have up here an address auctioneer like that. So okay, I'll just leave it like that for now. Yeah, that'll be the end of this stream. Thanks guys for tuning in. I'm excited to keep working on this on Monday, and tomorrow I'm excited to get into Web3 Pi and maybe some other interfacing tools that can connect to smart contracts and interact with them.